All right, so here's basics IX practice. I hope this is one of your better ones, and I mean that honestly. So on number one, there's a couple of ways of getting to the correct answer. The first way, which is the quickest way, is to pull the 64. It's always the quickest way. If you can pull it, you pull it. And then you have minus 2 and plus 2 as your factors, 4x squared minus 4. The harder way, or the long way, there's a couple of honors kids in first period who probably won't get this, but whatever. The long way is to do 8x minus 16 and 8x plus 16, because oddly enough, we expect a 17-year-old to know 16 squared is 256. Anyways, both of those pieces contain an 8. And then 8 times 8 is the 64 out front. If you see Elizabeth Jarrett or Kendall Melton, tell them to make sure they factor completely. All right, number two, this is something that I was hoping on the last basics quiz would be something that just about everybody gets right, except for a couple. But it wasn't good. It was really bad, actually. Micah, figure this out. We're going to subtract 64 from both sides. We're going to divide by 4. And that's going to give us x squared is equal to negative 16. The opposite of a square is a square root. A lot of you need to remember to include your plus or minus. You have been told this repetitively. The square root of a negative is imaginary. So think of this as the imaginary root of 16. The square root of 16 is 4, so 4 imaginary units. X is plus or minus 4i. Find the inverse. First step in inverse is to swap x and y. So this guy who is y becomes x. And this guy who is x becomes y. Step 2 is to resolve 4y. So we're going to add 7. And I've been asking you guys to find inverses of logarithms. So this should be like super easy. So x plus 7 is 3y. And there's a lot of ways you can write this. You can write x plus 7 all over 3. Or you can write x over 3 plus 7/3 is y. It's really up to you how you write it. I don't care. Just one of the two. Domain, it's kind of a newer concept. If you have a logarithm with an argument, the argument is bigger than 0. This is my argument. It is all I care about. 5x minus 10 must be greater than 0. Add 10 to both sides. 5x is greater than 10. Divide by 5. X is greater than 2. Easy peasy lemon squeezy if you're willing to memorize some stuff. Number 5, you get to use the zero product property. 2x minus 1 is a 0. Or 2x plus 8 is a 0. Or 7x minus a quarter is a 0. So I add 1. 2x is 1. I divide by 2 and I get a half. I subtract 8. I divide by 2 and I get negative 4. I add a quarter. And then I divide by 7, and division happens in the denominator. So 1 over 4 times 7 is 1/28. 6, find the zeros of this guy. Now this guy is a quadratic. It's a quadratic. The leading term is an x squared. So your choices are factor or quadratic formula. Now, I designed this one to not factor, so it's not going to factor. There's no way to make this thing factor. So pick out your letters. A is 3, B is negative 8, and C is 1. And I want to remind you that this is not an Algebra 2 standard. It is an Algebra 1 standard. Sing this stupid song, x equals negative b plus or minus square root b squared minus 4ac all over 2a. What's this little message down here? Yes. Sorry. Anyways, plug in. And x is going to be opposite of a negative 8, which is 8, plus or minus the square root. Remember to wrap. It's very important. Minus 4 times a, which was 3, times c, which was 1, all sitting pretty over twice a, which is 3. So inside of this guy, there's a negative 8 squared, which is 64, minus 4 times 3, which is 12, times 1, 12. And 64 minus 12, I feel like, is 52. So we have 8 plus or minus a root of 52, both pieces over a 6. 8 over 6 is 4 over 3. Believe it or not, being able to simplify that leading number usually makes these things 50-50 on a multiple choice test. The state's not trying to kill you, they're trying to see if you know something. Now, root 52 is most likely divisible by 4. I'm quite certain it is. I believe it is a root of 4 times a root of 13, which is 2 root 13. So plus or minus 2 root 13, still over a 6. And we have one more reduction left, 4 thirds plus or minus root 13 thirds. All right, moving on. We're on 7. Factor this thing by grouping. Grouping is where you focus on the first two and then the last two. So the first two terms contain x cubed. If I pull x cubed from x to the fourth, I have x. If I pull it from that, I have plus 4. Now, this factor has to repeat, all right? I'm going to have x plus 4. Again, I can create the x from a negative 7x by pulling the negative 7. And I am left with x cubed minus 7 times x plus 4. It's an easy factoring by grouping problem. There's nothing else to do with it. So, done. 8 is function notation. You're supposed to find f of g of x, which is better written in my mind as this, because that's 2x plus 1. This means find f of 2x plus 1, which means every x in f is 2x plus 1. So I'm going to start writing that down. F has a 3, then it has an x, which becomes 2x plus 1, then it has a minus a 2. Not everybody can do the distributive property. 6x plus 3 is what you get, minus 2. And there you go. That is fog of x. 6x plus 1. It's really not that hard. I didn't even make a square or nothing. I noticed that this problem on your last test probably had about a 2/3 pass rate, and it's one of those things that everybody should be able to do. Like, it's something that's supposed to be in 99 percentile. Get this. So we just keep practicing until you do. Anyways, you're being asked to find g of 4 first. You know, you do this first. G of 4 is going to be the root of 6 times 4 minus 4, which is root 20, because 24 minus 4 is 20. Now, root 20 is a root of 4 times a root of 5, which is 2 root 5. Oh! So now that you've done that, your new goal is to just kind of put that in there and find f of 2 root 5, which means that that x is going to become 2 root 5. Now, on the test y'all took last, I counted a lot of people wrong for leaving an answer like this. This is only partially credit. Because I keep telling y'all this, if you can do something, you should do something. You know what 3 times 2 is. It's 6. So 6 root 5 minus 4 is the answer I'm looking for. All right, determine if x minus 3 is a factor of this using synthetic division. Remember, this says x minus 3 is a 0, so x is 3. When you enter or leave parentheses, you have to, parentheses of a factored form, you have to change signs. So a lot of kids will probably do negative 3 when you should be doing 3. Your coefficients are 1, -1, -2. There are no x's. 0 and -24. Need that placeholder. We drop the 1. 3 times 1 is 3. -1 plus 3. By the way, I'm doing DMA, drop, multiply, and add. -1 plus 3 is 2. 3 times 2 is 6. -2 plus 6 is 4. 3 times 4 is 12. Bummer. That stinks. This was supposed to work. It sure doesn't, though, does it? I bet Milbrath made a mistake. I wonder where the mistake was made. Yeah, anyways, it doesn't work. We're going to get 12 and we're going to get a 36. So let's make that a 36. And that way, by the time y'all have seen this, it's fixed. I just need to remember to change that. Now, because the remainder is 0, x minus 3 is a factor. Only because the remainder was 0 is that true. I'm going to do one more, I think. Odd that it goes from, okay, it's good. An arithmetic sequence has a third term of 4 and a sixth term of 13. What is the first term? So a picture is worth 1,000 words. And good test takers, they learn to draw. You're either drawing on paper or in your head. So I'm talking about 6 terms here. I need 6 blanks. I don't have to have 6 blanks, but it helps. I know the third term is 4, fourth, fifth, sixth. Sixth term is 13. So let's find the difference. And this is arithmetic, which means we add or subtract. We do one of the two. 13 minus 4 is 9, and there are 3 places. I have to add the same thing 3 times to grow 9 units. 9 over 3 is 3. So 4 plus 3 would be 7. 7 plus 3 would be 10, and 10 plus 3 would be 13. So this is the pattern. The first term, this guy would be 4 minus 3 because you're working left. And then this guy would be 1 minus 3, which is -2. That is the easiest way to come up with those. 12 is going to be where I stop. I gave you the formula. You just need to make this thing look like y equals mx plus b. The difference here from -5 to 11 is 16. This is your first term. And then we're just going to plug into this guy. So the nth term is the first term of -5 plus, because there's a plus, n minus 1 times a 16. And you can't say that this is an Algebra 2 skill, because it's not. It's an Algebra 1 skill. This is, I've seen Garner teach this lesson. So we have -5 plus 16n minus 16. And then we combine like terms. We have a 16n minus a 21. That is the nth term. That is the rule. And this is where I'm going to stop for a day because, as you can tell, it's already after 3 o'clock and I got up here at 6, so I'm done. Not getting any more free work out of me today.